Okay, let's dive into a little walkthrough of how to get started building a project with RISC Zero. So we're at risczero.com. We can pop over to the docs and head straight to the getting started page. And it says to harness the power of ZK, you'll need to first write an application for the RISC Zero ZKVM. Second, generate proofs for your ZKVM application. And third, integrate your proofs into on-chain applications. So this diagram is maybe a little bit small. Here's a slightly bigger version of this diagram. At the top, we can see there's 3 steps. We need to build a ZKVM application, we need to generate proofs, and we need to integrate those proofs into blockchain applications. And then in the middle layer here, we can see those 3 steps sort of split out. On the left, we have ZKVM application development, which we suggest starting with the ZKVM Quick Start, or there's a Hello World tutorial that's also a good option for learning about ZKVM application development. And then in the middle, we recognize that once you've built a ZKVM application, you're going to want to generate proofs for that. So while you're building, you probably want to use dev mode, which skips the proving, enabling really fast prototyping. If your application involves privacy, you may want to use local proving. So the ZKVM is available either in a mode where you run it locally on your own hardware or in a remote proving context where you ask our proving service Bonsai to generate proofs. So the remote proving is going to offer substantially faster proving because we parallelize the proof generation on Bonsai. But you should be aware if you're sending your proofs off to Bonsai for proving that whoever is generating the proofs can see all of the internal information about the program, including any private inputs. So if you want to generate a proof about private inputs, you maybe want to generate your first proofs locally to manage those inputs. And then the third step on the right here is about blockchain integration. Once we've generated proofs, we need to post those proofs on chain, and then we need to have those proofs verified on chain. And we provide an on-chain verifier in order to facilitate that process. So for the blockchain side, we offer a Foundry template that makes it really easy to get started with a sort of cohesive project involving the ZKVM application side and then also the Solidity contracts involved. So let's pause there. I hope this is a useful orientation, and we'll follow up with more. Okay, let's dive into a little introduction of how to think about ZKVM applications and how to start building ZKVM applications. So the big picture view is that you're going to need to write an application for the RISC Zero ZKVM. You're going to need to generate proofs for that application, and then, assuming you're trying to do something with blockchains, you're going to need to integrate those proofs into on-chain applications. And in this video, I want to dive into the first part here of how do we get started writing an application for the RISC Zero ZKVM. So if we click on this link from the Getting Started page, it's going to pop us down to the Quick Start. But before we dive into the Quick Start, I want to just rewind a little bit to consider the question of just like an overview of the ZKVM. And in particular, I want to scroll down on the ZKVM overview to this diagram here in order to sort of just contextualize the pieces of the system. So the ZKVM lets you prove correct execution of Rust code. So you're going to provide some Rust code. The guest code is what's going to get proven. And you're going to compile your guest code using the Cargo RISC Zero tool into an ELF binary. This is like the RISC-V format of binary files. So then you're going to run your RISC-V binary in the ZKVM, which is essentially this box here. So the ZKVM is going to spit out a receipt, and you're going to be able to use this receipt on chain to prove correct execution of your Rust code. So inside the ZKVM, there's some kind of implementation details that you don't really need to worry too much about at this point. But just to sort of introduce you to the idea, the executor is going to produce a bunch of the executor is going to produce the execution trace, which is split into a bunch of segments. So the session is the entire record of your giant computation, or maybe it's not a giant computation. But let's say that you're running some large computation in the ZKVM. The session is the full record of the complete computation, and it's going to get split into segments, and then those segments are going to get proven, and those proofs are going to get aggregated, and then you're going to end up with a single succinct snark that you can post and verify on chain. So that's the kind of overview to the ZKVM. The thing that you're going to need to focus on most in order to sort of successfully develop a ZKVM application is the guest code, which in order to learn a little bit more about writing guest code, we could pop into this doc here. So the guest functionality that you really need to focus on most is the guest needs to be able to read inputs. It needs to be able to, I guess I'll highlight here instead, needs to be able to read inputs, needs to be able to write private outputs to the host, and it needs to be able to commit public outputs to the journal. So this is just for like during execution, maybe there's some input output between the guest and the host. You're going to use the write functionality. And if you want to have something actually appear in the receipt, you're going to use the commit functionality. So there are some links here to some of the kind of most important functions that you're going to need to play with. Each of these are going to point you to the Rust crates for the associated functions here. And then we are also provide here some tools for debugging and optimization. There's also a whole optimization section later on here. So I think that's enough for now as a kind of orientation. We walked through the overview and the guest code. There are, of course, a couple other docs here that you can take a look at yourself if you're interested in reading a little bit more. Thanks for watching. Okay, now let's dive into getting started with building a ZKVM application. So we're on the Getting Started page. We click here. We end up on the Quick Start page. If you've never used RISC Zero before, you probably want to start on the installation page. And you're going to need to install Rust. You're going to need to install the Cargo RISC Zero tool. So you're going to use these commands to install the Cargo RISC Zero tool, and then you'll get a printout saying it's ready to use. You can confirm that you have it installed correctly with this command. So then we can pop over to the Quick Start. So on the Quick Start, there's 5 steps. We need to install the tool chain, which we already just walked through. Then we're going to use the Cargo RISC Zero tool to create a project. We're going to sort of orient ourselves to the project. We're going to run the project in dev mode. This is skipping proof generation to just enable things to move quickly when you're building. And then finally, we're going to see how to turn dev mode off in order to actually generate a proof for your program. So step 1, install Rust, install the toolchain. Step 2, use the Cargo RISC Zero tool to create a new project. Step 3, orient yourself to this new project that you just built. So maybe you just want to poke around in the directory, but maybe you want to take a look at this Hello World tutorial, which will sort of walk you through a step-by-step guide of the pieces of your new template project that you just built. So in particular, the things that you're wanting to make sure that you're aware of how to do is how to share data between the host and the guest, how to commit outputs to the journal, and how to generate a receipt and interact with the receipt. Okay, so once you've kind of oriented yourself to the project, or you could even skip this step and just go straight to, I'll learn about it later and I just want to run it. This command will skip proof generation. This is dev mode is skipping proof generation so that you can kind of build quickly. And if you turn dev mode off, then you'll be able to actually generate proofs. So at the bottom of the quick start, we have a little bit of additional information about how to collect information about how many clock cycles your program runs. The ZKVM supports computations of unbounded size. If your programs are large, we're going to split the computation into a bunch of segments. So this is just like each segment consists of 1 million clock cycles. Yeah, and that's the full quick start. So I will point out that if you are looking for some more advanced materials, there's instructions on how to generate proofs here, how to optimize your ZKVM applications here, and how to integrate your ZKVM applications into blockchain contexts here. So happy building and see you soon. Okay, let's talk about options for generating proofs. So you've written a ZKVM application and you're ready to start generating proofs. Hopefully, while you were developing, you were using dev mode so that you didn't have to wait for the proof generation. But now that you are ready to generate proofs, you need to make a choice between whether you are wanting to generate proofs locally on your own machine or whether you would like to request that we generate proofs for you using Bonsai and send the proofs back. So the advantage of using Bonsai is that it's highly parallelized. So this means that the proofs are going to be substantially faster than they are on your own machine. Recall that if you have a large computation, when we're proving it, we're going to split it into a bunch of segments. And when using Bonsai, each of those segment proofs is going to be generated in parallel, whereas if you're using your own machine, each of those segment proofs is going to just be proven one by one sequentially. So again, the advantage of remote proving is it's substantially faster, as well as you don't need to worry about the liveness of your hardware and the demand spikes of your application. We will have Bonsai available to manage dynamic spikes in demand. The main reason to consider generating proofs locally is if your inputs are highly sensitive information. In particular, it's important to note that although the output of the ZKVM is a fully zero-knowledge proof, whoever is generating the proofs can see all of the innards of the system. So if you aren't willing to have your secrets leave your own machine, then you'll want to generate your proofs locally on your own machine. Once you generate those proofs, they can be distributed with full confidence about the privacy of the information. It's a fully zero-knowledge proof that comes out of the ZKVM, whether it's generated locally or remotely. So those are your options for proof generation. I will note on the local proving, there are options to run on CPU and GPU. It looks like they're not documented on this page, but if you go to the main repo and you go to the feature flags on the main repo, then there is the flags for CUDA and for metal are listed here. So those are your options for proof generation. Happy building. Okay, let's talk about integrating ZKVM applications into blockchain applications. So at the core, what you're going to need to do is post proofs on chain and then have them verified on chain. And if you click on this link for integrating your proofs into on-chain applications, you'll find your way to our sort of orientation page for blockchain integration. This is, let me zoom out a little bit so that the sidebar is visible. So yeah, we're in the blockchain integration section of the docs here. And this diagram kind of gives you an orientation to the conceptual view of what's going to happen. Assuming that you are using Bonsai to generate proofs, you're going to request a proof from Bonsai, and Bonsai is going to send the proof back. And then that proof is going to get published on chain, and then it's going to get verified on chain. So that's the sort of conceptual frame here. We provide this verifier, and in our Foundry template, you can find starting points for the on-chain app contract and what we call the publisher app here. So I'll click into the Foundry template and zoom in a smidge. And I'm going to sort of speed through this. This is similar information to what's on the other page with a little bit more granular detail into different parts of the repo here. So quickly, at the directory organization level, there is a contracts folder which includes the relevant Solidity contracts, and a methods folder which includes the relevant ZKVM application. So inside this methods folder, you'll find the guest code. The guest code for this example is even. You can learn more about writing guest code with this guest code 101 file. So that's my initial orientation here. There's probably more details that I should orient to, but the initial places I'll point you to is this contracts folder contains the Solidity stuff. This methods folder contains the ZKVM stuff.